Hello again and welcome to Jason's in the House. I'm your host, Jason Parisella, real estate agent with Keller Williams Realty here in Beverly. And tonight we're going to be talking about radon. So you're going to see shortly we have an apparatus we're going to be explaining. We have a lot of great information for you. So I want to introduce our guest today. It's Josef Camillo from Camillo Environmental Group in Andover. Welcome, Josef. It's nice to have you on the show.
Thank you. Thank you. I appreciate you inviting me.
And why don't you start out, tell us a little bit about your company, yourself, how you got into the business.
Sure. I was not always into radon mitigation. Radon mitigation was a part-time job for me. I started out as in the high-tech business. I was an electrical engineer working for a company, and one day a manager of mine walked into my office and said, "Joe, my wife is testing for radon. We're finding it, and I don't know how to fix it." And I said, "Dan, I don't either. What is radon?" So that's how that all started.
Now, when was that?
That was in 1985.
Oh, wow, okay.
While I was working in Boston for a company called Teradyne. So from 85 on to 92 was basically part-time. I got involved with the state. The public health department did a fantastic job putting together seminars and educational seminars on radon for a couple of weeks, and then the EPA came in as well. So we got some really good training. So from 85 to 92 was part-time, and then in 92 I had to decide whether to continue in the high-tech or go with radon. I decided to take radon. It was much nicer.
Did it didn't, I mean, this whole phenomenon, radon's been around for...
Radon's been around forever. Radon is a byproduct of radium. As radium decays, it decays into radon and also a lot of other elements, but the other elements are solid, so they stay in the soil. But radon happens to be in a gas form, so it can travel very easily through soil, and the house acts like a very large shop vac which draws the gas. In the soil, this gas is under positive pressure, so and the house is on the negative pressure. It just pulls it right through,
right in.
And it stays. The house, especially nowadays, where it's so well insulated, it's very tight. It tends to reach a saturation point and be fairly high in some locations.
Now, so radon's been around, it's never going to go away. When did the state start really having any type of standards or education about it? Sounds like it was about that period you got into. It was amazing how quickly the EPA went after this
radon.
What triggered that, do you think?
In 1984, there was a gentleman by the name of Watrous. He was an engineer at a nuclear power plant. Now, as you work in a nuclear power plant, as you come out, they test to make sure that you don't have radiation exposure on your body, on your clothes. Well, for some reason, he was the only one amongst a dozen of other people that he worked with that showed excess amount of radiation in his clothing. So they thought, this is bizarre. So they said, okay, when you're way home, from home to work, we're going to test you as well. And the alarm went off as he was entering the building. And this is how they found out about radon. They went back to his home and found levels exceeding 2,000 picocurie per liter. This is in Pennsylvania. And it was right after that the EPA got involved. And as a matter of fact, Mr. Watrous became a radon mitigator afterwards as well. So, but that was a long time ago. The EPA did a phenomenal job of coming on board quickly, setting up a process that people like myself could use to effectively mitigate homes and buildings. And so congratulate to them.
Yeah. So you talked about radon's a natural occurrence, a gas that comes from the ground.
It's a radioactive gas that comes from the ground.
It only comes from the ground?
Soil.
The soil?
Exactly. Now, a lot of times we get calls where people want to test for radon, which is always a good idea, and simply because they have ledge in their basement. But we see very little radon coming from ledge. As a matter of fact, in 26 years I've been doing this, I have yet to have a house with radon emanating from ledge.
Because that's a common thing that I hear as a real estate agent. Everybody says if the house is built, it all comes from bedrock and ledge.
That's right.
So you're saying that radon can't or isn't in...
It is not.
It doesn't penetrate into the rock.
It is not. At least the years that I've been involved, I have yet to see a house that actually had ledge giving off radon gas. The source is usually in the soil. It's radium in the soil. As radium decays and it decays to radon, and there's a gas, so it travels into the house. And it could be, the source could actually be quite far from the house. And as long as there's communication, there's a path, the house will draw it right in.
So it could bypass one house and go to the next house?
Absolutely.
Depending on what?
Absolutely.
So there's no rhyme or reason if you have one house in a neighborhood that has high radon, the next house could have low radon?
Absolutely. Absolutely. The only way to find out is to test. I see it all the time. We have subdivisions right here in Beverly, as a matter of fact, that we've had very, very high levels exceeding 100 picocurie. And so as far, maybe we should talk about picocurie, what that means.
Let me interrupt you for a minute, because you were talking about the ledge, and I wanted to, I've heard another thing too with these granite countertops.
Yes, good point.
Does that, I've heard home inspectors and people talk about these countertops are giving off radon.
I have an interesting story.
Depending on where the granite came from.
And I'll try to make it quick. I had a customer of mine from Wenham call me about 2 years ago. She was very concerned about her granite countertop because she saw it on television, and I guess it was very popular a couple of years ago.
Yeah.
Well, I said, fine, we'll go and test for radon, and then if there's radium, the radon that is coming off the granite countertop, we'll be able to detect it. As a matter of fact, with a machine that I have here. So I did. I put a continuous monitor on the first floor, and then one upstairs as well. She wanted one all the way in her bedroom. It's not a problem.
Right.
In fact, they were high. Okay, so now, is the radon coming from the granite countertop, or is it coming from the basement? We tested the basement. All the radon in the basement was quite high. So all her radon was coming from the basement right through the house. It's a good thing she tested it. We found no radon coming from the granite countertop. It was not an issue at all. As a matter of fact, we've tested probably close to 30 homes with granite countertops, and I've yet to find one.
Okay.
So it's not.
So I wonder where that
common.
all came from. I mean,
it's possible. But
it's not something
common.
to be a concern. It's from the soil.
I would say no. I would say it's not a. But certainly a concern is radon, general radon coming into the basement, into the house.
So if I call you too, and I want to get my house tested for radon, I have an unfinished basement. Mm-hmm. Where are you going to test it?
That's a good question. This is something that we run into all the time. What is the protocol?
Right.
What is the EPA? And it's really, it's common sense. If you have a house that has, say a fairly new house, that has a potential for the basement to be finished, or you're spending time there with some sort of a shop or exercise room, then it would make sense to test that environment, because you're inhaling that air.
Right.
And if the air has high radon, it's a problem. But if you run into a house that has no capability, no potential for finishing the basement, and your ceiling height, say, is very, very low, you're only down there to maybe check the heating system and run back up, then I would not test the basement. I would test the first floor. It makes sense to test the area that you're going to be spending time.
Okay.
And
that makes sense.
Yeah.
Okay. Because a lot of times the home inspector will put it in the basement.
It's
just put it in the,
part of that is lack of understanding.
Yeah.
It's lack of understanding the protocol. So we're getting there. More and more home inspectors are starting to become more aware of the protocol, and a lot of them have gone to classes. So
yeah,
eventually they'll get it right.
Right. Yeah. There's so many different things you hear. We're going to talk about why is it a concern. Before that, I just thought of something. When you have a dirt, does it matter if your basement floor is concrete or if it's dirt? Some of these old fieldstone foundations with a dirt floor. Are you more likely to have radon without a slab, a concrete slab on the floor? It
really depends on how strong your radium source is and what sort of communication you have to the house.
So it will go right through the concrete with no problem?
It will go through the concrete cracks. It won't penetrate. Radon, as a matter of fact, that sheet of paper you have will not allow gas to go through. Radon has very low penetrating power.
I see.
But if you have a slight crack on that concrete, it will come through because the difference in pressure, where the house is pulling it, it will just flow right through.
Okay.
But there's no penetrating power to radon gas, which is primarily alpha particles.
So you're better off having a concrete slab then?
Yes.
Than having dirt?
Yeah, in general.
Yeah.
Yeah, for moisture purpose as well. It's best if you can have that. Yeah.
So why is radon a concern?
Radon is a huge concern. The EPA has looked at this for the past 3 decades, and bottom line with their studies is that we have a lot of people dying per year because of radon gas, and its last statistics I saw was 21,000 people per year died due to lung cancer from radon inhalation. That's a problem. That's half of the population of Beverly, and that's every year.
Right.
So we need to do something to educate people to test to make sure that at least they're aware that this easily preventable gas can if it's there, can be mitigated.
Yeah.
Or at least they'll be aware of it, and they can open windows just temporarily to reduce the levels, and at some point hopefully put something in place that is more permanent to get rid of it. God knows we certainly have enough carcinogens that we're exposed to, and this is a simple one, very, very simple to get rid of.
Yeah.
So
now, so people can understand a little bit about what you would need to do to get lung cancer from radon. I mean, talk a little bit about the levels and how that relates to somebody actually getting radon. How many years it would take somebody, for an example.
That's a really sticky point because we don't know.
Yeah.
Your makeup is different from mine and everyone else, and your exposure to, let's say, 10 picocurie will be impacted differently from my exposure, and that's just on our genetic makeup.
Yeah.
It's a risk factor. It's a risk factor. The higher your radon exposure is, the lower the time.
I see.
So it's a lot like if you use a bow and arrow type analogy, where you're firing this bow one at a time, trying to hit a target, let's say 25 yards away. It's going to be tough, especially if you're not used to it. Like I'm not very good with that. But if I were to take 100 arrows at one time and fire, now my probability of hitting that target is going to be significant.
Yeah.
It's the same idea. And
the more, I would imagine too, the more time you spend inside your house.
The more time. It's absolutely.
So, yeah.
Absolutely. It's so important that people test. I've been doing this for 26 years, and I'm always surprised at how many people still don't know about radon gas.
Right.
And very important that they become aware and at least test for it.
Yeah. Okay. So how do you know if you have radon? What's the process?
By testing.
Okay,
by testing.
So what is that all about?
There are a couple of different ways to test. A homeowner can go to a hardware store and pick up activated carbon test kits. These are vials or actual canisters that they place in the living space, or in this case maybe basement if it's a livable basement, or if they're spending time in the basement. And you basically place it about 2 to 4 feet off the floor for about 3 days, and then you mail it to the laboratory, and the laboratory will analyze and tell you how much radon is there. Now with carbon, you definitely want to have 2, so you can look at the average, because it's only going to give you one number.
Now, when you do the carbon, isn't it actually giving you the highest? The carbon, like the highest level.
Yeah, I personally
compare that to the one that I know you use a different one too.
Yeah, yeah, I personally
because it's just giving you the most it has in one, right? The most it's accumulated within that period. Carbon
looks at the last 12 hours. It's not a true integrator.
Okay,
and,
so
a true integrator is like a continuous radon monitor, and we can talk a little bit about, because I have one here, that grabs onto radon every hour and puts it in the memory, and it doesn't lose that, because radon is always changing. It's always going up and down, and we really need to look at that average.
The averages,
The average is what's important. That 4 picocurie that the EPA put out as a guideline, that's an annual average.
Okay.
And it doesn't, the spikes is not important. It's this.
Yeah, so a carbon could say 5, because it spiked to 5, but the average could be 4 on a continuous radon test.
Yeah, exactly. The carbon sort of looks at the last 12 hours.
Yeah.
And it forgets. It forgets before, because of the process that it goes through. It's called an adsorption and deadsorption process. It's grabbing onto the radon on the surface of the carbon. It lets it go. That's deadsorption, and then it brings it back again. So it's always doing that, and it loses a lot of that information.
I see.
Now, you can certainly use carbon, do 2 of them, but a better way to go is with continuous radon monitor, the electronic test. Okay. Yeah.
So why don't we show, if we can show this
this
device
is,
here. That's what you use for the...
This is the what we call a continuous radon monitor, and there are several manufacturers of this particular type of monitor, the CRM, a continuous radon monitor. We happen to use these. They are fantastic, very accurate, the results that you get. We typically leave them in a home for about 48 hours to 72 hours, and I like going 3 days because we can get more data. And as a matter of fact, after 3 days, we download the data to the laptop, print it, and I can show you what the result.
Yeah, let's take a look at the report.
What that looks like. And if for some reason, if it's not coming, let me know. This is actually a customer of mine in Belmont that that we had a test done recently, and
I think we got to, just keep it, yeah.
So right here, so if we look at this axis here, this is the concentration of radon, and when as high as 100 picocurie, and then it starts dropping. And the beauty of such a system is that it integrates over time. So we can get the average, and in this case the average was 45.6 picocurie per liter. And all this information is incredibly valuable to radon mitigator. We can actually use this.
At 45, you're talking about 40
45 picocurie.
It's way over the limit. It's way over. This is a high reading.
So it's over 10 times higher than the EPA guideline.
Okay.
And as a matter of fact, when you start to go over 40 picocurie per liter, there's a linear relationship to lung cancer. It starts to
after 40.
After 40, from 40 on.
There's
a direct correlation, a linear relationship to lung cancer. So it's extremely important.
So what was the highest one on this one? What was the highest rating?
The highest one. Let me see if we can put this back on. Let's see here. Yep, here we go. Yep, here we go. This point right there. That's 2 hours at 100 picocurie.
That's 100, but the average is 45.
The average is 45, and you can see what happens here. It was a particular window of time where we had wind and rain, and typically what happens when it's windy and it's raining, the radon tends to go up exponentially, and this is in fact what's happening. And then as the time settles, it drops substantially. But also we have airflow in this particular house. The air from outside is getting under the slab, pushing all this gas, and we're witnessing that.
Okay.
Yeah, it's pretty, very impressive. This you only get with a machine like this.
Machine like that. Yeah.
With a continuous radon monitor. Again, there are several companies that manufacture these, and it's definitely the way to go.
Yeah.
It's very, very accurate.
Okay. So I just want to make sure we cover this before we get too far into the program. This device that you have. So now you do the test, then you have your results.
That's right.
Now you also get involved with recommending a mitigation system.
That's right. That's right. So so you start by testing, and then once you have your result, now you can make a decision, and hopefully it's low, and the decision is we don't do anything, which is great. But if it is high, now you need to figure out what the design is going to look like. So the first step is to conduct what's called a vacuum test. And we probably talked a little bit about this. So given your slab, we want to know what the resistance of the soil is. It's a very simple test, and sometimes it's referred to as a communication test, where we drill 2 holes through the slab diagonally across. We put a suction on one hole, and then we measure the other hole with a micromanometer. And that will tell us whether there's communication. For example, if you have crushed stones, you're going to have fantastic communication, because air can flow through the stones very easily. We can create these pressure fields. Wonderful. If it's sand, much more difficult. So we may end up with other additional suction points to run some tests. It may be that the actual penetration through the floor to draw the gas is more central than somewhere in the corner. So that's the second piece of it, if it's found to be high. And then we can sit down and figure out, what's the sizing of the fan. And if you actually look onto the sprite here. So
this is the device that I mentioned earlier. Yeah. So that's an actual. That would be the pipe coming out of your basement.
Yeah. This is a PVC pipe attached to a radon fan. Typical system that we have.
Now you just there's only one. Well, is there always only one pipe, or you got to put interconnect pipes?
No, that's a good question. I will admit this. When I first started 26 years ago, it was always half a dozen pipes, because I didn't know what I was doing.
You just put them all together.
We'll just put as many pipes as possible and pray. Now, we've learned over time.
Yeah.
Most homes will get one penetration through the floor, one pipe through the floor.
And it just goes right into the ground, right into the floor.
Into what we call a radon sump.
Yeah.
And this is based on this engineering work, this study that we do initially to look at the communication. Because that will give us the data that we need to design a system, an effective system.
Right.
Because what you want after a system is installed is a complete vacuum under the slab. And that's why they call it sub-slab depressurization. And as long as we maintain a vacuum under the slab, then it's impossible for the gas to come.
Right.
Because we're drawing it before it has an opopportunity to come into.
Basically, you're redirecting into the pipe.
You're redirecting it.
And now, where does it go from when you get into the pipe?
Two different locations for the fan. So once you have your pipe connected to through the floor, the fan can go on the exterior of the house or in the attic of the house. Those are two locations. And sometimes if you have a attached garage with no living space above the garage, we can do that as well.
So you have to bring the pipe all the way through, up into the attic?
Yes.
Okay, it's almost like a vent pipe, a main sewer pipe. Yeah.
It's just like the regular plumbing pipe going through. And a lot of times if you have closets that line up between first and second floor, we can run this easily.
Just right through, yeah.
Most of the time easily, not all. Every once in a while you run into issues, but
right.
For the most part. But most of the installations are going on the exterior because there's really no way to run through the house.
So you're just popping it right out the side of the...
It goes up, usually in the back of the house, so you don't see it from the front. I don't particularly like PVC pipe showing in front of a building.
Right.
So we keep it on the exterior, so as you're driving you don't see it. And this pipe here is what would be going up alongside of the house, past the soffit, and so we go around the soffit and the gutter about a couple of feet.
I see.
And the reason for that, the reason we want this pipe to be up high is because the concentration of radon is very high coming out. It's no longer, let's say you start at 10 picocurie in the basement. This could be 10,000 coming out.
It's because it's collecting it all in the one pipe.
It's concentrating.
I see.
Absolutely, it's concentrating. So we want to make sure that this pipe is venting safely away from windows, so it doesn't re-enter the house.
Now, is it actually? I just thought of this. Is it actually a radioactive gas? Is it radioactive?
Radon is radioactive.
Radioactive.
It is radioactive.
So it's like being exposed to. It's radiation.
It's just radiation.
Yeah.
It's a radiation exposure. And this is why it's so important that people pay attention to it and test, because you can stop a potential problem from occurring, which is lung cancer, by getting rid of this radon.
So you get the thing, you have the system set up. Why don't you? I think we can plug that in.
We can plug in it, and then we can go over the mechanics of it
and see if you probably. I think you'll be able to hear it.
So for people who do have, if you have this in your home, you'll probably see this pipe in the basement and this gauge here. This gauge is very important. It's called a manometer, and it is here to let you know that the fan is running, because the fan tends to be fairly quiet. A lot of times you can't hear it. As long as the two columns are different, they're not equal, that means the fan is running.
I see.
But even, and this is very important, we can unplug it. So if it were to look like that, where two columns are equal, we definitely want to make sure that the homeowner calls the radon mitigator that installed it, because there's a problem.
Okay. Yeah.
But in addition to looking at this on a regular basis, and then maybe once a week at least, I would highly recommend testing for radon, at least annually. Once a year, call a radon company or someone who does testing to come in and run a test, or go to a hardware store, pick up a couple of test kits, run a test, simply because this is on doesn't necessarily mean that your radon is being evacuated.
I see.
It's not 100%.
So the system could change over time.
System
what
can
your
change
requirements
over time.
are.
And we have seen that.
Okay.
We have seen it. It's extremely important. Even if you have a system, still test annually.
Okay. Anything else you want to point out on that system there?
This the one question that I often get from homeowners is, this pipe is running through my house, through my closets.
Right.
It must be radioactive. No, no, it's not radioactive. It's air with radon going in. It's not going to be warm or hot.
It doesn't go through the PVC.
It's not going to go through the PVC. Remember, even a piece of paper
you mentioned
can block the gas from going through. So This is perfectly safe. It's all on what we call negative pressure. So let's say your 2-year-old gets a hacksaw or a sawzall, then decides to play with it and cuts the pipe. It's still safe. It's not. You're not going to get radon to come in because it's under a vacuum. So what will happen? Air will go inside.
Okay.
This portion is dangerous. This is the positive portion of the system.
So after the fan.
After the fan,
okay.
The pipes that's after the fan is under positive pressure. This has to be well sealed and it has to be in a location where there's ventilation.
Right.
This is typically why the fan is in the attic of the house or on the exterior.
I see. Okay.
But they're very efficient. They're in addition to radon reduction, it's also helping with moisture a little bit because it draws the moisture from underneath the floor.
What about the electrical needs? I mean, if that fan's running, it's always running?
It's 24/7. This one here probably will cost a homeowner, depending on where you are, where your kilowatt per hour is, $45 to $50 a year.
Oh, so it's
fantastic.
Okay.
No, for what it's doing, it's wonderful.
Yeah.
Yeah.
Okay.
It's and it's never to be turned off. Once it's running, you just. Yeah, this will run for years. I've been doing this 26 years, and I have a lot of customers with systems still running after 26 years.
Wow.
Amazing.
It just keeps running.
Yeah, it just keeps running. Every once in a while you'll get a failure, but it's not too common.
Yeah.
But they're nice systems.
Okay. You want to leave that running? You want to?
No, we can disconnect.
Yeah, maybe yeah.
Yeah. This is probably, I would say, the majority of homes will use one of these. Every once in a while, we'll run into a particular house that this will not work. So then we move into what's called an air-to-air heat exchange system.
So when would that not work? What would...
This will not work when we perform this suction test and we cannot get a vacuum. We cannot get communication. Then, because if you can't get this communication, this is not going to draw because it won't create these pressure fields. There's too much resistance.
Right.
And then this is when we look at an air-to-air heat exchange to change the air.
So that's okay. So that would actually be installed in the basement.
Yes.
And then you would just be changing air constantly to make sure that...
Yes, we have X amount of air exchange taking place, and by changing the air, by bringing fresh air into the basement, we're diluting the radon. We're not taking the radon, we're not preventing it from coming in. This prevents it from coming in. With air-to-air.
Catches it before it even gets in there.
Exactly. With air-to-air, we're diluting it.
Diluting it.
That's
now,
right.
when you... so that report was like 45, real high reading. What if that homeowner just opened they had basement windows, they just opened the windows and left them open all the time? Or even if you left them open and you stuck a fan in the window, is that really, how much do you think it would go down?
As a temporary fix, absolutely.
Does it go down? How much, if it was 45 before the fans and the windows open, what do you think it would be?
You can knock just about all this radon down to almost background if you can ventilate properly. And that's the key. The key is cross ventilation.
Yeah.
So let's say you put a fan in one window, and then you open the other window, so you're pulling air through. All that radon is just going to go down to background level.
So ventilation is important in general.
Ventilation is very important, but the problem is in the winter months you can't leave windows open.
Right.
And also
actually, in the
moisture.
summer, I was thinking, once you have like central air in your home too.
That's right.
You're not even opening any windows.
That's right.
So you don't want to leave the basement windows open because you're bringing in hot air.
That's right. All that moisture.
Right.
So typically, people do not open windows for radon mitigation. They go to the extent of putting in a system
I'm just thinking,
to prevent it. But as a temporary measure,
you want to probably get ventilation as much as you can. And you mentioned that earlier too. The homes that are more tight now with all the green, the energy efficiency and all the insulation that they have.
Yes.
These houses are so tight.
Yes.
And I think that even goes along with some of the, we've talked about this in prior shows, with mold and all this kind of...
I mean, that's probably another
nothing breathing,
another topic, another day. I'd love to talk to you about that. I'm really scared, based on what I'm seeing in the construction of these homes, where they're super insulated, and now moisture cannot leave.
Right.
And it stays there. And what happens when you have moisture? Eventually you'll have mold. You'll have wet windows and doors.
Because I think that's another thing that's come up more and more is mold. I think it has to do with a lot of this.
Absolutely.
So tight,
because of excess moisture. If you don't have moisture, you're not going to have mold. It's air-to-air heat exchange, I feel, needs to be in every home. especially the new highly insulated homes. You need to have
you should just automatically put that in the basement. Yeah,
absolutely. In the basement, entire house.
Entire house.
Absolutely, yes. Yeah, I would not design and build a super insulated without.
So if you have a forced hot air system and central air, can the air-to-air heat exchanger be attached to that?
Absolutely, yeah. The only problem is not a constantly running system, because at some point your HVAC will stop running.
Right.
Maybe it reaches temperature, it's just going to stop running. So a better system would be to separate that, put it a completely independent, make it independent from the HVAC system, because again, it's a constantly running system.
So it would be a separate system?
Yes.
Okay. Yeah, and you need all the ductwork and everything? Or no?
Yes. Yeah, and the time to do it is obviously when you're constructing.
I see.
Not to say you can't do existing homes, but it's when you're constructing.
Right. Okay.
But
we have a few minutes left, so let's just go through. Talked about methods, common causes is obviously coming from the dirt. So ways to avoid exposure. If you just, whatever, economically, you just don't have the money to do a system, or you're concerned, what are some ways to just avoid it before you can fix it?
Well, we sell these radon and mass. No, I'm just kidding. The way to avoid is, or to mitigate temporarily, is by opening windows, get some fans moving.
And stay out of the house.
No, not necessarily.
I mean,
if you can open the windows, if you have windows in the basement or a door, then you can get some ventilation, and that will reduce the radon fairly quickly. But obviously, long term, you want to deal with it in a permanent fashion.
Right. Right. Okay. Why don't you? Because you've got a lot of great information. How can somebody get a hold of you if they wanted more information about a system, testing, any questions whatsoever about radon? Sure.
My office number, I can...
You can just go ahead,
Yeah, my office number is 978-470-0055. And if you dial 475, you're going to get Depot Pizza, which I get a lot of calls on Friday especially. So, and my cell phone, I'd be happy to provide my cell phone. My cell phone is a great way to get a hold of me. It's 617-448-9972. 24/7. I'm always available.
Excellent. You must be, so you in general, are you finding yourself more busy, less busy, or?
It's,
or is it just
I started radon in 85 and 92 full time. Because of radon, we also ran into radon and water. And we didn't talk about this. So radon and water, and I found it early on, became a real issue, because now we mitigated, we put the subslab, the pressurization, we took the radon out from that was coming in through the basement floor. Come to find out, the radon in the house is still high. Well, it was high because there was so much radon in the well water.
Oh, so now we had
so now I had to learn about water chemistry.
Yeah, you're talking about
And so from looking at radon and water, we expanded our field of business into water filtration.
I see.
So between radon and water, it's been keeping us pretty busy. Yeah.
Excellent.
Yeah, we do all sorts of
Well, I know your name
systems.
comes up quite a bit in the real estate world, because we're always looking for people to get opinions on radon, and because it comes up, it's pretty common. People test for it at a home inspection.
Oh, yeah, no, it's become quite prevalent.
Yeah.
I think just about every transaction people are being tested.
Yeah.
And there are certain spots in areas in Beverly that we're seeing some fairly active area, like Thaxton, Thoreau section. Very active area.
Okay.
But
excellent. Well, great stuff. And before we close, I just want to thank BevCam and the staff. We appreciate their help. If you have any questions for me, feel free to visit my website, which is jasonparisellateam.com. And until next time, we'll see you later on. Bye-bye.